Oh, okay. Nice to see you again. I think it's been quite a long time we have had real lessons. I watched my old lesson notes, and I seem to have written in. I think it was 15th for 2 weeks. No, it was not this. Wait a minute. On 15th of this September, I wrote that I'm feeling a little bit ill, and after that, I was. Oh, the sound is low. You don't hear me. Um, yes, 2 weeks ago, I was starting to get ill, and I was a couple of days on sick leave, and I think we had some lessons. Yes, on 19th of September we had lessons, and after that it has been quite hard time. But I think I hope this will. I have gone through this illness right now, even though I still have some kind of problems to speak, and my ears are not well, but I think I am getting fine now. Um, about this course, I will show you the Moodle page. We have gone through these basic calculation rules and right angled triangle, and we had before. I think it was about 2 weeks ago. We had this oblique triangle or triangle which was necessary, not right angled triangle. So any triangle at all, and we had these some formulas there for oblique triangle, cosine rule and cosine rule and sine rule. I don't know what is the problem in my audio. Audio is echoing. I don't understand what is the problem now. I'm not sure if it is okay now. Well, let's continue. If there is problem with the voice, just write there in chat box. So we had these formulas there, cosine rule and sine rule there, and we made some examples there, and then we I opened some assignments there in the Moodle. There are in this part of Moodle you find these assignments which should be returned to me, and if you open that, one thing you all should do as soon as possible is to ask your personal number of for these assignments for this course, because I will show you the Excel sheet which we will use. So if you open the assignment sheet, it looks like this. So there are these assignments. There are totally 10 right now there, but in the beginning you see only the pictures of the problem, but there is nothing in here. Puuttuu is Finnish word which means is missing. So it means that there is something missing here. So there is some kind of formula here, but you can't see it. But you should ask the number what you will use when doing these assignments. For example, if you send me a message where you ask your personal number, I may probably give you, for example, number 55. This is just an example. So if your number is 55, you will write it in this yellow box here. I will write, for example, 55 there and press enter, and now I can see those problems there. As you see, there are problems stated, and I think in every problem there is some picture there, and in the picture there are some letters, and in this text you see the values for those letters. For example, in this assignment 4 with the personal number 55, the value of L equals 63.2 millimeters. So it means that this measure here is 63.2. But those values change and differs, and they depend on your number. For example, if your number is 40 in this assignment 4, I don't remember what it was. It was for the number 55, but probably it was different number, 68.2 here. So this is the situation in all these assignments. They are the same assignments for everyone, but everybody has different values to start calculating. Yeah, so send me email as soon as possible to get your personal number. Right now I have given that number for only 20 students, and there are almost 70 students there, attending this class. So there is or this course totally in campus and online. So there are lots of numbers still to be asked. There are some problems. I know that many online students especially has many kind of problems to start joining these classes, and that probably means that I have given these deadline dates for these assignments here. I am not going to be very strict on those dates, because I know that there are very big problems for many students to even start studying this course. There are some technical problems and some practical problems also. So this is not so strict days, but they are some kind of advice, what would be the good timetable to work those assignments and to get them done in time. Totally there will be about 30 assignments, and right now yeah, yes, just ask. What was the date? October. you said you have some final exam, and what was the date in that exam? Sorry, I couldn't hear. Can you repeat? October 3. Yeah. Yes, but these dates are not strict. I will make some corrections there. No problem at all. Yeah, okay. Um, and also one point which I have changed after that first time I spoke of these assignments. I'm not quite sure what I have talked about with you and what I have talked with campus group, but there is. I've seen that there are some problems in this case here. I try to find where I wrote the first completing the course part here, and there I I first wrote there that after the deadline time I will check those assignments sent to me. Well, that was not good rule, and this also I didn't like this that after corrections, if there were some errors or mistakes in your calculations, there was a rule that if you correct them, then after corrections you would get only half points per assignment. But I found that very stupid rule, because that causes that student doesn't or they don't send those assignments to me in time. So they are checking and trying to get it correct, and because they are afraid that not getting the maximum points of them. But I think it is better that if you get problem solved, you send that immediately to me, and I check that as soon as possible. For example, today I have got some messages where some students have sent their assignments. I have uh, checked those and I give some comments. If they are okay, so it's okay. You get 1 point per assignment. But if there is some error, I will tell where that error is, and you have possibility to check and correct those errors and send it again when you think it's okay. And after corrections, I will give the maximum points for assignments. So I would like to encourage you to ask help if you have problems with them. So it is not wise to just be some kind of teacher who only checks the assignments in the end of course and then gives some points, and nobody learns anything because they are only getting some points for the course, but not actually learning anything of mathematics. Let's hope that this is a better rule that I made. I think it was yesterday I wrote that red text there. So, for example, this assignment one, I will put another number there, such number that nobody has that. For example, this problem. This is a problem concerning right-angled triangles. So you will use the Pythagorean theorem or sine or cosine or tangent. It depends on what you have to solve. For example, in this problem, it is asked the length of FG. So it is this small part here. This should be calculated. What is the length of this part here? And there has been given you three lengths of these triangles, AB, AC, BE. You find them from this picture, and then some angles, CBD. By the way, I'm not sure if this is clear. What does this mean? For example, this notation angle CBD here. It means the angle which you find from this triangle CBD in this picture. It is this triangle here. If you can see my cursor moving there, this is CBD, and it is the angle in the middle letter. So there is B. So it's this angle here, which is drawn in the picture. This is angle CBD. So these three letters tell you the triangle where you find that angle, and the middle one tells the exact angle of that angle. And where we do it in paper, yes, you are not, I don't want to get any Excel sheets when you are answering. Calculate it, those assignments as normal mathematics problems with pen and paper, and then take a picture, or if you have some scanning applications in your mobile phone, take a scan, so scan it to PDF format and send that to me with the email. But only one assignment per email, so I need to get have possibility to be very clear what assignments I have checked and what not. So it is important to send them in every assignment in a new email. And be careful for the roundings, because in these problems they are every time asked to give the answer in some precision. For example, in this assignment 1, the final answer should be correct in 1 decimal place. So it is okay if it is correct in that precision. But if it is not correct in that precision, so I will give you the back, and you will correct. There are probably some rounding errors there which have made so that which have caused that the final answer is not accurate enough. Yes, this is usually the one kind of problem in the beginning of studies to calculate accurately enough. I have if I find that text where in the assignments page, I try to write this kind of part there, which I tell common errors. So that what kind of mistakes there are usually done. I don't necessarily mean your group, but in my experience, in my other students also, who had made some assignments which are similar as these you have got now. So this too rough accuracy is quite common error. So read these carefully. But as I said, you don't miss any points if you made mistakes in returning the assignments. You have possibility to correct them later. Yes. Okay, today I will go through some formulas for area and volumes. I have here many books of formulas, and I will pick some formulas there and give some examples how to use those formulas. I have to show another thing again. I forgot this. Let's go again here. Here is study material for geometry. There I have put here some pages of one formula book which I happen to have myself and which is written in English language. So I have scanned there some pages. I will show this mathematical handbook. I'm not sure if someone even has this kind of handbook. But there are. I don't mean that this is the best one, but this is one example. And I have taken there some pages there. I scanned there pages from 5 to, was it? Well, I will show it here. You see the same here. There are some pages. I think I have scanned the pages to the from 5 to 10 there, and I will go through some parts of these formulas here, and one thing also which I think it's important is to go through some concepts in Finnish language also, when you sometime may find some material written in Finnish language, not necessarily only in mathematics but in other courses also, so or in some Finnish internet sites or etc. So I think it is good to somehow get some kind of dictionary of Finnish language. I shared you the one Excel sheet which was a dictionary for students in this course, and I'm glad that I have got some translations there. This is this kind of Excel sheet that I have written there some English words in the first column here, and then there are not so many, but some there are already, and then my translation to Finnish language, and then there are Bengali, Nepali, Urdu, Turkish, Sinhala languages there. Some students have already filled this sheet there. There are some empty lines there also, so if you know these words, I would be glad to get that filled. And some languages, I think there are, in my opinion, these are the native languages for most of the students in these courses, but I'm not 100% sure. There may be some languages which are not in this list. If your language is not there, so I would be very glad to see there also your language. But this is not any kind of assignment for course, but for your everyday knowledge of languages. It would be very nice. For me, it was very nice to see that there are some languages in the Indian continent or in that part of world where they speak, in my opinion, very similar languages to each other. If I compare these words there to each other, but you may be in different opinion. Okay, so this I will probably take this I think this is see better here. So there is these first these formulas for area calculation of areas. I think we had this rectangle already in Finnish form. It is suora kaide or suora kulmio. I will write it there. Let's put the title here. In Finnish, pinta-aloja ja tilavuuksia. And in English, areas and volumes. Pinta-ala is area and tilavuus is volumes, and yes, I am recording this view here, but now I started also the recording of this Teams session. I forgot to record that, but this will go to YouTube, so you will find these always from the Moodle page after the classes. So let's take this again. Suora kaide or suora kulmio, which is rectangle. Yes, rectangle. Well, the letters may be different ones, but in this formula book they are marked as A and B. This would be in English base, and this part in English would be either height or altitude. I use merely this height word. This height in Finnish, it is korkeus. It means this part here. And base, it's kanta. This part here. Well, the area is very simple. Base times the height. So let's put it here in written form. Easy one. Then we have this kind of figure here. Let's take a Finnish word for this also. Parallelogram. It is hard word for me. Parallelogram. It is not at all as Finnish word. Here you see, by the way, the altitude. There it is used here. Somehow here it was called width. Of course, it means the same. So this in English it was parallelogram, and in Finnish suunnikas. The word in Finnish suunnikas, probably that comes from the word suunta. By the way, that is not a good choice. Oh, sorry. Suunta is direction. So maybe this word comes from the idea that there is some kind of direction. See here in these opposite sides, they go in the same direction. So probably that name in Finnish came from that idea. Well, this formula for calculating the area of parallelogram or suunnikas, it depends on what you know, what is known in the problem. For example, if you know this angle here, for example alpha, and then you know this measure here, let's call it B, base. So in this case, and of course we have to know some kind of length of the side. Let's call this A, this length here. And now we may calculate this with the same formula as the rectangle, because actually we could do so that if we cut this figure with this kind of line and we take this triangle away here, and we see that because these lines are in parallel, they go with to the same direction. So this triangle here is actually the same size as this triangle here. So actually you may calculate this area with the same formula as we did with rectangle, base times height. Now we have this B here, this is base. It only, if we think it as a rectangle, this B only moves to the right a little bit. So, but this length is the same. This is also B because this length is the same as this length. So this rectangle has the base B, which is the same as this parallelogram. And then we need the height of this figure, and this height here is possible to count with this rectangular or right-angled triangle, because we have this hypotenuse which is now A, and we have this angle which is alpha, and if we count from this right angle triangle the length of this side here, we get it with the help of sine. So this h here is the same as A times sine alpha. So the area would be b times h, or if we use the knowledge of the length of this height here, so we could replace the h letter with this a sine alpha. So this is the same as b times a times sine alpha. And of course we made write those letters in opposite direction, a times b times sine alpha, as it was made in this book. Actually, in this book, that angle was marked with the Greek letter theta. It's not so very good here, but I will show from this page. So this angle here is a theta angled. AB sine theta. I use the alpha angle alpha there. Well, then we have of course triangle, and well, this is so easy one. We have calculate, or you and everyone of us has calculated the area of triangle many times in our lives. Base times height divided by 2. It is the one formula. Base times height divided by 2. Then we have this figure here, trapezoid in English. Trapezoid. So it would be for example this kind of figure. It means that these sides here are parallel. They go to the same direction. And this is, in English, this is called trapezoid. In Finnish, we call it puolisuunnikas. This is actually because this half, this puoli means half. So actually this means half of the parallelogram. I don't know if this is very good word for trapezoid, because it gives you maybe some kind of wrong feeling how to calculate the area. It is actually not half of the parallelogram, but it means that in the parallelogram you have these opposite sides which are parallel. So that's why it's called parallelogram. So these sides are parallel and these sides are parallel. And in this trapezoid or puolisuunnikas, only half of those parallel sides stays. So if we compare these figures there, so both have these sides parallel, but in this picture these sides are not parallel. So if every time when we have this kind of figure, they are called puolisuunnikas. It is actually quite easy to calculate the area of this kind of figure. I will use the same letters and than in this book, A and B and H. So let's call this A and this B, and then we have the height of this figure, H. So the area of this kind of figure is it would be more easy to understand this if we had I'll take another picture there. For example, if we have this kind of figure here, this is more easy to understand. This is also trapezoid because these sides are parallel. And for example, if this is A and this is B, and this is if I turn this figure 90 degrees, so this would be H, the height of the figure. And in this figure, it is quite easy to understand that we get a rectangle from this trapezoid by dividing or drawing a line in the middle height, so in the midpoint there. So if we draw this kind of figure, we get a rectangle. So this red here is rectangle. This triangle and this triangle, they are both equal size. So how do we calculate the area of this? We have base, which is called H in this picture, and then we have these heights here in the left side there, A, and in the right side, B, and the height in the middle of the figure is the average of these. If this is, for example, 6 and this is, for example, 10, so the average or mean of those numbers is 8. So the average height of this figure is 8. So it is average of these values here. And in this figure, it is the same holes, even though it is not so easy to see. I'm not going to prove this formula for you, but here you may also think with the same way. We have 8 times the average of these two side lengths. So average you get by, for example, that average of 8 you get by adding these together, 6 plus 10, and dividing by 2. 6 plus 10 is 16, and we divide it by 2, it equals 8. So here the same holds, A plus B divided by 2. So this is a formula for trapezoid. So this H here is the, I will draw right here. This is the distance between parallel sides. It is more easy to remember this formula like this, because the figure can be in any position, but it is always the same logic there. This means the distance between the parallel sides, and then we take the average of the two sides there. Average of the lengths of the parallel sides. By the way, in this formula book there are formulas for perimeter of this figure. I'm not sure if that is very useful formula. Actually, I've never used this formula, but I saw that in this case we have these not so common trigonometric function cosecant here. It means same as 1 divided by sine theta or sine alpha, cosecant. But as I said, mostly this area of trapezoid, if we need to calculate it, it is more easy to calculate with the help of rectangles or triangles. You don't need to remember any this kind of perimeter. I say area. I meant perimeter. If you need to calculate the perimeter, it is easy to calculate with the help of the lengths we know, and with the help of these rectangular or right angle triangles, it is possible to calculate this hypotenuse there. So it is not so hard thing. So actually we don't need any this kind of formulas. Then there are I will skip this regular polygon right now. I don't think it is necessary right now. Probably I will return to this, but I don't think it is actually important in this point. Circle, one point is good to notice that many times in these formula books, the area or the formulas for area for circle is given in radius form. For example, in this case, you know the radius of the circle, and the formula is given with the help of radius. But many times the thing what you know from the circle isn't the radius, but it is the diameter. So many times it is more handy to use a formula for area of circle is to use diameter. Yes, there was a question concerning the assignment 1. That is a problem where you use only rectangular for or right angle triangle. So this assignment here, this is also only an example. This is a problem where you need those formulas which yes, there was also an answer. Yes, they are all right angle triangles. So you should be possible to solve this problem with the Pythagorean theorem and sine, cosine, and tangent. But let's take that circle. In Finnish, I think we had that probably. I will draw the picture here. So this is R or R, and let's call this with the letter D, diameter. In Finnish, säde. And D, diameter, in Finnish, halkaisija. Well, this is the very well-known formula for area of circle. The name. This was circle in English and in Finnish ympyrä. Ympyrä. The perimeter, it is shown not so very well in this video, but it is 2 pi r. Perimeter 2 pi times r. By the way, if you need to calculate with pi, don't use the approximate value 3.14 because it or 3.14 because it is too inaccurate value. For example, if you use the phone calculator here, you find the pi here, so there is a button for that. So use that, so you get more exact value. Or in this old-fashioned, is it? It's not. It is. This is a calculator which is about 40 years old, I would say, but it is still okay for this course. Here we find also the pi. It is there. I don't know if you can see, but with this and this button we get the value of pi. In this calculator, it depends on the calculator which you would use, but for example in this calculator the pi button is here. Here you may find the pi and the value of pi. But this 3.14 is too inaccurate. Don't use that in those assignments where you need to use pi. In assignment 1 there is not anything missing. I think there is everything is given in the problem. But many times we don't know the radius of the circle. We know the diameter, but we need to calculate the area. Many times it is more simple to use a different formula for area when using diameter. And for example, we could do, if we don't remember the formula, we could do this like proving this. So we have this formula with the help of radius, and we remember that radius is half of the diameter. So in this case, pi times d divided by 2 squared. And we have this fraction format here, d divided by 2 raised to the power of 2. So this exponent or power of 2 goes to the d and to the 2 in the bottom side of this fraction. So here we could write this pi times d squared divided by 4. And this is also a formula which is quite easy to remember. It is not so hard because mostly when I have to calculate the area of circle, I will use this formula here. And the same here, this perimeter ympärysmitta. Let's put that. Ympärys, it is almost the same word as word ympyrä, but this is more universal. It means something which is around you. So it tells this word that you are going through this line here. You are going ympäri, around that circle. And mitta is actually, I think it's the same as the Greek letter Greek word meter, meter. Originally from Greek, I think that word is from. It means measure. So this is a measure of the length when you are going through going with this path of the line of the circle. And if we have this diameter or diameter here, which is 2 times r, so here we have 2 and r, so this would be easily pi times the diameter. If we know the diameter of the circle, we may calculate the perimeter with very easy way. Okay, I will have a 50 minutes break now. So uh, 14:28 in Finnish time. Right now it is 14:13.